I'm Ryan Konopinski. I work for GE Energy Consulting, and I'll be talking about the concept of planning for interconnection of wind plants based on net maximum capacity. This presentation is in regards to the IEEE Green Tech conference that it was presented there in April of this year, 2015. Here's a quick agenda for the discussion. I'm first going to introduce the generator interconnection study process, give a little bit of history about this, and then walk into the concept of the interconnection planning based on net maximum capacity, or NMC, and then we'll look into some of the implications of net maximum capacity planning with regard to the current interconnection procedure. Then we'll follow up with some just suggestions and recommendations for how to incorporate NMC into the current generator interconnection procedure and agreement. So let's take a look at some of the history surrounding the interconnection study process. So FERC back in '96 decided that there was a bit of a lack in a standardized process, and so it put an order, FERC Order 888, which was effectively to help promote competition of the wholesale electricity market, as well as to provide equal transmission access to generation developers. The Order 888 provided some initial guidelines for non-discriminatory transmission access, and then in the following year, Order 889, FERC basically put in place a rule that introduced the web-based open access policy, OASIS, which again further promoted additional market competition. After several years, FERC realized that there were some inefficiencies and a lack of an official standardized process. So then in 2003, they came out with Order 2003, which created an official standard interconnection procedure and agreement, the LGIP and LGIA. And through several revisions, they finalized the Order 2003-C in 2005, and this order applied to generating facilities that were greater than 20 megawatts, and there were some specific requirements for wind plants. So let's now take a look at just a high-level overview of the flow of how the LGIP works. So the figure here on the right-hand side, this was copied or borrowed from an NRO report, and essentially just kind of walks us through the timeline and flow chart of the large generator interconnection procedure, or this FERC Order 2003-C. It begins with a generation developer requesting an interconnection, the beginnings of the interconnection procedure, and after several feasibility studies, including a system impact study, it may end with a generator interconnection agreement between the generation developer and the transmission provider. Note too that this process is fairly lengthy, and it can take upwards of over a year to complete if there is, in fact, an interconnection agreement signed. During the study process, the system impact study utilizes several bits of information that are provided at the interconnection request. So essentially, again, when you begin this interconnection procedure, there's a request and there's some details that are needed regarding the facility that is planned to be built. Some of this information includes the group installed capacity, or GIC, which we'll be talking about a little bit more, the turbine types, number of turbines in the plant, as well as ratings of the turbines, the manufacturer, model of the turbines, as well as a simulation model. And again, that simulation model is used in evaluation of risk to the power system in the SIS, or system impact, portion of the feasibility studies that go along with the LGIP. Also note, too, that there could be certain circumstances that after the interconnection request has been filed and the LGIP begins, the system impact study may need to be reevaluated, or essentially the large generator interconnection process might have to be restarted again. Certain situations could apply to a change in the capacity of the plant facility or to changing of any of the facility equipment. So let's look into some scenarios that could lead to reevaluation of the system impact study, or basically re-beginning this large generator interconnection procedure. A developer may be incentivized by for economic reasons to upgrade or propose to upgrade various hardware or control features within the wind facility, which could increase the plant capacity as well as the functionality of the plant. And these are upgrades that would have been separate from those that would have initially been proposed during the original interconnection request filing. So again, due to economic or possibly grid performance incentives, the developer may want to upgrade the facility. This upgrade could happen either during the project development, so from the time that you've begun the request until the time that an agreement is signed, or possibly after the facility is in commercial operation. So now, what exactly constitutes a refiling of this interconnection procedure or reevaluation of the system impact study? So the FERC Order 2003C has some definitions which try to define what would fall under or what would warrant a restudy of a proposed plant. They have two articles, one that defines a material modification as well as one that defines a plant increase. But some of these definitions and these articles are somewhat ambiguous, and in the end, the interpretation of these definitions is essentially left up to the transmission provider. So due to some of these ambiguities, reevaluation is left up to the transmission provider. So if the transmission provider deems that a facility would need to be restudied, there are potential consequences to the generation developer, one being the position in the queue. So once you've taken your place in the interconnection queue or in line, if you have proposed particular upgrades that a transmission provider has deemed to be fall under either the material modification or plant level increase, you could get bumped from your place in line, which again you could incur additional study costs as well as additional time. Likewise, the entire economic feasibility of the project could be jeopardized, and essentially the project may need to be scrapped due to the fact that additional transmission reinforcements may need to be put in place in between the original interconnection filing and the time that and by the time that you have performed the second round of the system impact study. So let's talk now a little bit about the concept of net maximum capacity planning versus the current practice of group installed capacity planning. So here are just some quick definitions. The group installed capacity, or GIC, is just the nameplate rating of the wind plant. It's essentially just the gross real power of the plant, defined by the number of turbines and their nameplate ratings. The net maximum capacity, or NMC, is the group installed capacity minus any plant losses, where losses could come in the form of balanced plant losses, which could be electrical losses, it could be equipment unavailability, or forced outage or scheduled maintenance. So if the facility loses a turbine, or if a turbine's offline, or multiple turbines are offline for a particular period of time. Operational losses to the wind turbine due to environmental factors, as well as controlled curtailment of production. So now this slide introduces tries to introduce the differences between the current planning practices using group installed capacity versus the proposed practices of net maximum capacity. So under the group installed capacity, in this example, we have this wind facility with 9 turbines in it at a particular rating. So the group installed capacity is, again, just the gross rating of the facility. And the system impact study in this instance has defined a particular interconnection limit. So basically the net contribution that at this particular interconnection location that does not exceed or violate any reliability concerns of the power system. So in this case, after electrical losses, environmental losses within the network, the net injection into this facility under perfect conditions, or essentially under full rated conditions, and under the assumption that all the plants or all the units are online, the net injection is less than the reliability limit. Therefore, the facility would not, pose any violation to the system impact study. But under certain circumstances, you could have, again, additional losses, or that could come in the form of a unit on either forced outage or maintenance, and the net injection at the interconnection location would even be less. As such, the facility is essentially operating less than optimally, given the reliability limit of the plant connected in this particular location. On the contrast, the concept of net maximum capacity comes in and basically tries to plan for the net injection equivalent to the reliability limit. So in this case, same location, but we have either A, you could have either added an additional turbine, or B, maybe you've decided to perform some sort of upgrade to the turbine, either a hardware upgrade or maybe a software upgrade to the turbine. In this case, the total group installed capacity of the facility is much less than in the original case, but utilizing a self-curtailing mechanism of the facility, you could guarantee that the net injection of the facility is equal to and does not exceed the reliability limit of the interconnection location. As such, the self-curtailment ensures that the interconnection limit is not exceeded, and so you're capitalizing on the most net injection that a facility could provide at a given location. This slide just tries to introduce the self-curtailing mechanism that could be utilized in conjunction with the concept of net maximum capacity. And what it is what we're trying to do is illustrate some field measurements from an existing 30 megawatt facility. This is a wind plant that's in Hawaii, and this dates back to 2007. So this is illustrating existing technology that's in use in the field right now. And what the slide shows here is this is a 2-hour window of field data measurements and a testing that's been performed overall, a window in here over 1 hour. So what we've got here is a blue trace that represents the megawatt output of the facility, and the kilowatt output of the facility, axis on the left-hand side, and this orange trace, which is wind speed measurements over this 2-hour window. And those measurements are in meters per second here on the right-hand side. What this measurements illustrate is that the wind speed has the production capability for the facility to produce up to rated output, so basically 30 megawatts of output. But when the test begins, we have actually curtailed the facility to 10 megawatts, 10 megawatt output, and then starting in 5 megawatt increments, the curtailment limit is essentially released and very tightly controlled, so that the release of the curtailment is very, very tight, and that there's very little overshoot. And the tests are basically performed over a 1-hour window. So again, this really just tries to illustrate that the technology exists, it's out there, and most turbine manufacturers have this type of capability. So now let's take a quick look at some potential implications of net maximum capacity to the current interconnection procedure. So again, as I had mentioned, for particular upgrades to a facility, again, whether it be equipment upgrades or software upgrades, there may be certain circumstances, again, left up to the transmission operator that might deem a particular upgrade to fall under a material modification clause or a plant level increase. So these categories of upgrades, again, either fall under control upgrades or hardware upgrades, where control upgrades could be just software updates to the existing hardware, where the hardware is left the same. Hardware updates come in the form of hardware changes, whether it be in the form of turbine ratings, so it could be a particular new turbine model that comes out, possibly a turbine type, or even maybe changing the turbine vendor. And in the end, the evaluation of whether or not a particular upgrade is deemed to impact the system impact study is through evaluation of the short circuit power flow and stability risks to the power network. So essentially what the transmission provider is trying to evaluate is whether or not these upgrades would pose any additional risk beyond the original equipment that would have been proposed. So in the end, again, it's left up to the transmission provider, but what we're trying to demonstrate is that there are certain circumstances where upgrades would not warrant a material modification or fall under the material modification clause and should not necessarily need to be restudied. But there are also certain circumstances where most definitely a change in equipment or an upgrade to a particular plant or a change in the plant hardware would definitely warrant a restudy, which again would cause the generation developer to re-enter or refile an interconnection request and begin the LGIP process all over again. So for a quick example, a situation where a generation developer most likely would not necessarily have to refile the interconnection request would be for a software upgrade, or in this case, the example highlights here a wind boosting upgrade in conjunction with a self-curtailing control feature, as I had highlighted on the previous slide. So in this instance, there are no hardware changes to the facility. So essentially, the short circuit contribution, the power flow, and the dynamic response of the facility would be identical, or if there was any differences, it would essentially be very, very negligible to affecting the system impact study. And in such a case, we feel it would not warrant the facility to be restudied. But on the contrast, there could be a situation where if a developer comes along and decides to change equipment vendors, so there are N number of turbines from vendor X, and they decide to go with N number of turbines from vendor Y. So the number of turbines and the size of the plant essentially remains the same, but you're changing manufacturers of the equipment. In such a case, during a fault situation, the hardware and the converters could protect differently, essentially causing a different fault contribution to the power system. So essentially, the short circuit study component of the system impact study would change or be different, and it could be significantly different to the point where this would probably constitute a change in the material modification clause, and therefore should probably be restudied under the LGIP. So now I just want to quickly follow up with some suggestions and observations that I've discussed in the presentation here. So the LGIP in A, we feel should allow for the concept of net maximum capacity planning. Again, this uses the self-curtailing mechanism available in many wind turbine manufacturers, and these LGIP and A should not just take into consideration the GIC, or the gross installed capacity of the wind plant. And what we're arguing for is that the net maximum injection at a particular interconnection point should be considered in place of just the gross capacity of the plant. And under certain circumstances, the system impact study would not be materially affected by the concept of net maximum capacity. But we have also argued that in certain circumstances, there could be a situation where the impact study could be affected by changes to the hardware of the plant. Also, too, the self-curtailing mechanism is nothing new to the power system industry. Thermal plants have been doing this for a long time. Steam and gas turbines definitely operate with higher nameplate ratings than they would be allowed to inject at a particular location, essentially just curtailing their output based on a power dispatch request by the operations folks. And with this, I have basically just tried to convey the concept of net maximum capacity planning in regards to wind plant interconnections. And that covers the presentation. Thank you.